Hey number crunchers, let's talk about function notation. Let's start with our fill-in notes. Here, we read this as f of x. So in the past, when we had something outside of the parentheses, that was always multiplication. Now we read this as f of x. It tells us our relation is a function. In the equation f of x equals x plus 3, x is the input, and f of x is the output. So remember, input is our x, and output is our y. So f of x is just another way of writing y. In the case of f of negative 2 equals 8, it's just faster way of writing that y is equal to 8 when our x is equal to negative 2. So our input is negative 2, our output is 8. So f of negative 2 equals 8 tells us that the input is negative 2 and the output is 8. F of 10 tells us that the input is 10 because that's where the x would be for the general equation, and the output is 5. Now, f of 10 equals 5 doesn't tell us what the actual equation is. All it tells us is that we would get out this point, 10 comma 5, when we put it into the f function. Now, just like when we are naming people in our class, we say that student, this student. If we're talking about a lot of different functions, function notation gives us a way, gives each equation a different name. So instead of saying this student, that student, the one over there, we could say f of x, g of x, or h of x when we're talking about lots of different equations. To evaluate a function, this word evaluate means to substitute the value inside the parentheses for x. So I'm substituting my input in place of the x in the equation. The result can be plotted on a graph as an ordered pair, x comma f of x is the same as x comma y. So let's try a little bit of practice. We're going to evaluate these functions for the inputs given below. Now in the black bar, I have a bunch of different functions. I've got f of x equals 1/2 of x plus 3, h of x equals the square root of x, j of x equals 24 divided by x, k of x equals x squared, m of x equals x minus 4, and n of x equals 3 times x. So my first problem I'm going to look at, it says f of 2. So what that means, I'm going to put it into the f function. So I take half of 2, gives me 1, add the 3, and I've got 4. Let's try h of 49. The h function tells me I take the square root of 49. So I'm looking for a number times itself that'll give me 49, and that number is 7. Now in the k function, we're inputting 0. So I'm going to take 0 squared. 0 times 0 gives me 0. Let's try just a couple more. H of 9 is telling me to take the square root of 9, which gives me 3. And n of 4, I go over to the n function, and that's 3 times my input. So 3 times 4 will give me 12. And m of 0, my m function is to take the input and subtract 4. So I take 0 minus 4, I get negative 4. Pause the video and try the rest of these examples and check in with your teacher to see how you're doing. Unpause the video when you're ready to look at the input-output tables. Okay, number crunchers, welcome back. Let's take a look at these input-output tables to evaluate the functions. We're going to complete the tables and then the ordered pair that we can put on a graph. So my first function is f of x equals x plus 4. I'm just taking the input and adding 4. So my first input is negative 3. I add 4 to that, and I get a positive 1. And my xy, or my x comma f of x pair, will be negative 3 comma 1. My next input is negative 2. I add 4 to that, and I get positive 2. So my ordered pair is negative 2 comma 2. Negative 1 plus 4 gives me positive 3. So my ordered pair is negative 1 comma 3. 0 plus 4 gives me 4, so my ordered pair is 0 comma 4. 1 plus 4 gives me 5. I've got 1 comma 5. And 2 plus 4 gives me 6, so my ordered pair will be 2 comma 6. Go ahead and try the rest of the tables. Check in with your teacher to see how you did.